Lesson 3 of Chapter 0 is on quadratic functions and equations, and we're going to talk specifically about solving quadratic equations. So the first thing I want to discuss is how every parabola or quadratic function has a minimum or a maximum. So how we determine that is if the a value is greater than 0, then it has a minimum. And if the a value is less than 0, then it has a maximum. So why is that? Well, if a is greater than 0, as you can see here, then the parabola opens up and it has no highest point, but it does have a lowest point. And then, of course, if the a value is less than 0, the parabola would look like this. It opens down, has no lowest point, but it does have a highest point, or a maximum. So keeping that in mind, you're going to be given problems like this, example 3, that says it takes an equation and we have to determine whether the function has a minimum or a maximum. So this parabola is going to open down. It would look something like this. And since that parabola opens down, then it's going to have a maximum. Part B then says find the maximum value of that function, and to do that, we have to find the vertex. To find the vertex, we use the formula, negative b divided by 2a. And if I were to do that, looks like we get 2 for our corresponding x value. And now to find the y value, I have to put 2 into that function. So if I put 2 into this function, I believe we get negative 12 plus 24 plus 11, which would give us 12 plus 11, which is 23. So there is the maximum point of this U-shaped parabola curve. And then part C says state the domain and range of the function. Well, domain is describing the left and the right of this graph, and this graph continues on forever to the left and forever to the right. So the easiest way, I think, to describe the domain when it's all real numbers is from negative infinity to positive infinity. You could also use this symbol. It's like a capital R. Usually they try to like bold it, something like that, which represents all real numbers. And then if we talk about the range is describing the up and down of the graph. Well, since this has a highest point but no lowest point, we'll say that it goes from negative infinity up to 23, and we need to put a bracket on that 23 because the graph actually gets to that height. If it stayed below 23, then we'd use a parenthesis on the 23, but since it gets to that height and equals 23, we use a bracket. Here's a better diagram of that particular function. You can see it's a U-shaped parabola curve that opens down. You can see that the vertex point is in fact at 223, and that it has a maximum point. And you can see the domain and range is described down below. Next thing I want to do is talk about factoring. Well, with factoring, we have quadratic functions, and what you need to do is you need to be thinking about the sum and the product. So, let's see if I can use my colors here. There's your sum. There's your product. So when it's set up in descending order, again, you can think of it as an A, B, and a C value. The B value represents the sum of your two factors, and the C value represents the product of your two factors. So keeping this in mind, on example 4, we need two numbers that multiply to give you 12 and add up to give you negative 8. So in order to do that, what we do is we draw two sets of parentheses, and we put an X at the beginning of each of them. And then our two numbers, let's see, would have to either be 1 and 12, negative 1 and negative 12, 2 and 6, negative 2 and negative 6, 3 and 4, negative 3 and negative 4. So if you consider all those options, There's only one that multiplies to give you 12 and adds up to give you -8. So your factoring looks like this. X minus 2 and X minus 6 still have an equal 0 here. So we factored it, but now we have to continue to solve it. So we set each factor equal to 0 and continue to solve. We get X equals +2 and X equals +6. Those would be the two solutions for this problem, which if we were to graph that function, we should see two x-intercepts, and they would be at 2 and +6. Now factoring on this problem is a little bit more challenging because we have an a value that's not a 1. When you've got an a value that's a 2, then what I do is I teach students to use the process of what I call send it to the back. And that's taking the a value and sending it to the back. So if we were to do that, we'd be left with an x squared minus 3x minus 28. So sending it to the back, you have to multiply the a times the c. And now we proceed to factor just like we would on the previous problem. Set up our factoring, and we need two numbers that multiply to give you -28, add up to give you -3. So that would have to be a -7 and a +4. So there's your factoring. However, since you sent the 2 to the back, what you're going to need to do next is divide each of these factors by 2. So that gives us x plus 2 here. And on this one, since 7 isn't divisible by 2, I put the 2 in front of the x. So there's your two factors. And now setting each factor equal to 0. And continuing to solve, looks like we'd get -2. And we'd get +7/2 or 3.5. Those represent the two solutions for this quadratic function.